Hi. In this lesson, what we're going to do is we're going to look at the PHP section of the course that's been posted. So we're going to go to Moodle and I'm going to log in here. And we're going to go, all the sections are the same, so we can go to IS601. And I'm going to expand this out so we can do full screen here. Let's go down here. And what we want to do is talk about this section. So in the readings, what we want to do is just talk a little bit about first the three principles in software. So a lot of times people, when they first start to learn to code, they focus on the syntax or the name of the language, and that's not really, or just the syntax of the language. What they really don't understand is that there is an entire and relatively easy to understand grammar of writing programs. And the grammar essentially boils down to, and we're going to talk a little bit more about this in a more sophisticated way, but there's an acronym for DRY, D-R-Y, and it stands for Don't Repeat Yourself. You'll see DRY all over the place whenever they talk about good programming. And there's a book called The Pragmatic Programmer, which is a legendary book that talks about good programming practices and ways to understand how to be a good developer. And here, basically, the DRY principle states that these small pieces of knowledge may only occur exactly once in your entire system. So don't repeat yourself essentially means don't repeat any lines of code. And what we're going to do in this video is I'm going to take a look at the project that you have to do, and I'm going to explain to you how that you don't have to repeat yourself. Now, one of the other things that we want to talk about here is what's called solid programming, which is a little more sophisticated version of don't repeat yourself. It specifically deals with object-oriented programming. So before we get into too much, let's just explain that there's basically three different types of programming. There's procedural. And procedural is essentially one function calls another function, and the program is loosely structured. It's not really reusable. And one of the languages that you'll find that's procedural is C. C's procedural. If anybody ever asks you what's the difference between C and C++, well, one of the major differences is C is procedural, and C++, the extended version of C, is object-oriented. Like, essentially, that's what the plus is object-oriented. Now, one of the things that and then the third type of programming is what's called functional. And, sorry, the second type of programming is object-oriented. Object-oriented programming is basically where you sort of relate real-world concepts and ideas to computer code. So, for example, there's two major concepts in object-oriented programming that you should understand about how to decide what to do. And in object-oriented programming, objects are things, people, places, things, and things can do things and can do actions. So objects are have what's called properties, which is, for example, with a car, the number of doors, the number of wheels, what kind of car it is. It's the properties that make that object what it is. And then objects have methods, and methods are ways of doing things. So it's like there's a method to do something. So objects have methods and they have properties. Now, also in object-oriented programming, there's another concept which is called a static. And a static is an action. So it's count, run, retrieve. They're just commands. Okay. Now, so like a command of run the program, that could be a static. A command of count, and then you would have a function called count. You send an object or you send something into it, and it will count the number of elements in the array or in properties in the object or whatever it is you want. So you have objects and statics in object-oriented programming. And as we evolve our understanding, you're going to see how this is done through the program that we're going to be writing in a few minutes. Now, in programming, and what we're going to be working on is there's generally three major areas. There's the solid, okay, so that's single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion. This is sort of the theory behind object-oriented programming put together in almost an academic way. In fact, it came out of an academic paper about object-oriented programming. Is how this got put together. And then we also see that there are the basic grammar of object-oriented programming, which is it an object or is it a static? And that's sort of is it a real thing or is it just an action? Is it a verb or is it a noun? You know, that's the sort of inciting grammar that you should have about object-oriented programming combined with solid. And then finally, there's what's called design patterns. And so in PHP the right way, they'll talk about this. So we'll be going, and they have the design patterns right here. So in here, here they have this link here to the design patterns. And what I'd like to say is that, have you ever written a program in your class and you didn't know whether or not you were writing it right? You didn't know how, you questioned, am I doing this right? If somebody who knew about programming was to look at my code, would they consider what I'm doing to be correct? And what happened was there is actually a fairly clear standard of whether or not the code is correct. Now, it's sort of like there's a degree of variation. Let's say code can always be more correct usually. So your challenge as a programmer is to sort of find the most correct, most efficient way of writing your program and be able to justify why you made the decisions you did in deciding whether or not an object was static, deciding if it was, deciding if something should be an object or if something should be a static. Did you follow solid, which is, or dry? Because like the first two letters of solid are basically where dry comes from, and we'll get more into that whenever we look into the program. And then finally, your challenge is really to use the design patterns as the tools that you have as a programmer correctly. So what you can think of is that these design patterns are all like hammers and nails and screws. These are all the tools that you as a programmer can use. And if we can look at this, so for example, an observer, and it's like, what's an observer? To implement a publish subscribe behavior to an object. Whenever a subject object changes its state, the attached observers will be notified. It is used to shorten the amount of coupled objects and uses loose coupling instead. So what they do is they give you an example. There's the UML diagram for it. Here's the code to be able to implement it. And it turns out that, a little over 30 years ago, this book, Elements of Reusable Object-Oriented Software, Design Patterns, this is like the Bible of computer programming. This has the foundational knowledge that all object-oriented programming and all of those design patterns came from. Basically, these four men were early adopters of object-oriented programming, and after many years they decided to write a guide for future programmers to understand all of the things that they learned over the course of, 10, 15 years of object-oriented programming on a commercial application. So this design patterns book is done in, I believe, C++, but here, for example, we have an observer in PHP. The insight into the design patterns and programming and why we're doing this in the course is that all of the programming languages that are object-oriented, like PHP, Python, Java, all of those implement the same design patterns. So in fact, the design patterns are the vocabulary of programming. It's like if you were a carpenter, you would need to know what a saw, a hammer, a chisel, a screwdriver were in order to call yourself a carpenter. Well, in order for you to be considered a programmer, these design patterns are things that you need to know in order to work collaboratively with other programmers, because I personally lead teams of different types of application developers, mobile developers, back-end developers, API developers, database developers, and we in our teams are able to communicate with each other, and I'm able to communicate to my team members that I manage to build a product using the vocabulary of the design patterns. Because if I say to somebody, I want you to use an observer to do some action, like for example, every time an email comes in, I want you to send a message to Joe that he needs to pick up the garbage. And in one case I wanted to do it in PHP, I would be able to get the PHP design pattern for an observer, or if I said to somebody else that only knew Python, I could tell the person that was going to do Python how I wanted to build, and they would be able to go and look up the design pattern, the reference code to implement that functionality. So if I said I want a Python observer, and I could look up I can see observer pattern in Python, and here they have all the patterns here. In order to do this with Python, essentially once you understand the vocabulary of the design patterns, the grammar of deciding whether or not something should be a static or if it should be an object, deciding and understanding the sort of structural grammar of solid or dry, because like just so you understand, it's like there's dry, which is a simple way of saying it, don't repeat yourself, and then solid is saying that there should be a single responsibility. There should be one line of code that's responsible for any one thing in your program. And then OCP is open close, which means that your function should be open for extension but closed for modification. So essentially what this comes down to is that in your programs you have to have one function per action, and that one action function relationship, you shouldn't ever have to consider that to be complete. You should be able to look at that code and say, there's nothing else that could have to do to correctly complete that one action. And so let's take a look at how we would design a program in using these ideas so you can see them in action. So what I'm going to do is I'm going to fire up PHP Storm here. And what I'm going to do is I'm going to pseudocode this program, and I'm going to explain along the way. I'm not going to run it. I'm not telling you exactly how. That's the next lesson that we're going to do. But I just want to show you how to think about things in this way, because if you've been a programmer before, you haven't done it, it's really important that you go and it's really important that you are able to, how should I put this, plan your program that you're going to make so that it works correctly. And then you go write it. So here, I've written this program, and I'm not going to iteratively write it. I'm going to go and explain to you how this program, pseudocode, this is real code, but this won't run. I didn't finish this or run the program. But this is, let's say, in grammar, written correctly. So we start at the top of the program, and one of the things that we want to see is that things are, with the S in solid, single responsibility, and then our functions are open for extension, closed for modification. So here I have a file name equals data.csv. When I go to $program equals new main, I say that what's happening here is I'm instantiating this object, main, which is going to be my program. Now, main comes down here. This is the class. A class is like a schematic. It's like a design for what your program's actually going to be doing. And in this, I have the constructor. Now, the first design pattern you're going to learn is the constructor. The constructor is the first thing that happens whenever an object is instantiated. Only objects that are instantiated have the constructor fire, and that constructor will not fire on a static method. So static methods don't have constructors. So only objects have constructors, and the constructor is automatically called whenever the object is instantiated. That's why we can do program equals new main, and we start it up. Now, there are ways to improve this program, which we'll talk about later, but right now we're actually going to use an object for the program. Later I'll just say that it actually should be used as a static because the program is running, not doing it. It's not an object. The program isn't an object. You're running the program. So if it's running the program, then it's a static. But in this case, I wanted to show you constructors, and this was the easiest way to get that across. So, and I'm not trying to give you all the code for the correct program. So, class main, I have public construct file name. The file name comes in. The file name gets passed to get file records. Now you see here, this constructor is open for extension, the close for modification. You see, we don't have to go into this constructor and change the name of the file name. We change the name of the file name outside of the program. So you could technically, maybe if you were going to make a command line program and on the command line you wanted to type in the name of the program and add an input parameter to that program, you could add the input parameter of the file name to the CSV file to it. So that we don't have to modify our constructor to have it open up the file. So what we got to do is take the file name in. Then the first thing we do is we got to go get the file records. Then here we come down to get file records. So we go and say if handle if open, and while this is not false, run this. So here what happens is that each line of the CSV file gets read into data. Then what happens is that I'm going to count the number of elements in the array, and then I'm going to read it into a variable or an array called records. Records, the syntax is an array, and the syntax is bracket bracket equals data. So an array is just what's called a data structure. So in, let's see, see if we can find a image of this. So if we did what's called a print R, we would be able to see that an array would have, this would be record 1, this is record 2, this is record 3. Usually the arrays start with a 0, so normally it would be 0, 1, 2, 3, and then this would be row 1, and these would be the fields of the CSV file, row 2, fields of the CSV file, row 3, fields of the CSV file. So that's what an array is. Array is the primitive, is the basic data structure that's inside of PHP that you have to work with to implement hashes and lists and maps and dictionaries and all sorts of data structures that you might find in programming. So coming back to here, we have records, and then we add data to records. Then we return records, and you see this could be improved. I think that actually I could remove this part right here and then just do something like data. And this is like, I haven't done this, but I might do something like this where I might do something where I'm just doing $records equals data, because whenever I have the assignment operator, which is the equals, it's going to take data and stick it into records, and then once this is finished, it's going to close the file and then return records. That would be loaded into here. Then we want to generate the table, so we would go to HTML table records, and we come down here to HTML class. You see how I'm organizing my classes into logical groups? So HTML, all the functions that relate to HTML would be in the HTML class. The functions related to CSV would be in the CSV class. I have Here, if you notice, I forgot to say this, if you notice the way I'm calling this CSV : get file records, and the rest of these are all called as statics. So CSV : get file records, I get the file name, and then I load it into records. This static is a command. See, it's get file records. And that command is being run. That's why it's a static. I don't have any objects in here yet, except for the program. But actually, what I'm going to do in the end, whenever we have this more well written, what you should do is you should convert this program to run as a static, and then you should, in the reading, you should be creating an object as you're reading the data that is going to be your CSV file. Because the CSV file, you have to think that the records in the CSV file are usually people, places, things, and if it's people, places, and things, then that should be an object data type, and the object data type would have properties and methods, and that's why for this program to be correctly written, you have to make the program run as a static, and you have to make the records that are being returned as an object. So what happens is you have an array. Remember, we looked at the array here, but what would happen is that you would have an object would be inside of here. So it would be row 1 object, and then it would be the names of the fields. Now, in running this program, what happens is so we go records, we get the file name, the table gets generated, so a table gets records, records comes down here to HTML, we pass in records, and whenever we pass in records, it starts to generate the table. So this is the table tag, this is the TR tag, headings. I'm array shifting over here to get my headings, and then I for each through my headings to get the value. I close out my each table row for my headings, so that's going to be the table heading code. This is going to for each. This is a loop. This loop is going to go through records, and then it's going to go through key value. So key arrow value, that is a syntax which takes the key of the array and then the value that's in the array. So this would be the 1 if this was row 1, and then this would be all the fields that are in row 1 that you would be able to then go for each again through to print out the field and have the value. Okay. Now I got this code off of Stack Overflow. So here they have some examples of this, and here's the one we used, which isn't actually correct. We modified it a little bit. But it's generally, this is the gist of the way the program should be written. Now, once we have the HTML here, we pull the HTML back, or return the HTML back. It goes into the table variable. Then here I do system : print page $table, and then print page passes down to here, the system class, and then I make a method called print page, and I pass page in, and I do echo page. I don't just echo the table right here. You don't do that. The reason why, that's bad grammar. Remember the open-close principle? The open-close principle says you should have, or single responsibility says there should be one line in your program that is responsible for each action in the program. So printing. So here anytime I wanted to print with this program, I would always call this print page method and then have one echo statement in my program. I wouldn't have a series of echo statements in my program. I would have one, and then I would call that function whenever I needed to print. Now, this also demonstrates the open-close principle, because this print function is open for extension. You could extend this with another class or override this with an object, which we don't need to know about right now. But it really means it's closed for modification. The echo statement doesn't take any parameters. There's nothing other than printing that it does. So echo $page is the simplest. You would never need to modify this echo in order to have it work. Now, let me explain why you do this. So imagine you're at work and you're working as a programmer, and one day your boss says, hey, we just got an update from the PHP standards committee, and the PHP standards committee that sets the standard of PHP, the language for the whole world, they decided that they're no longer going to have echo, they're only going to have the word print. So, you know, all those programs you were writing, well, what you need to do is go in there and remove all of the instances of echo and replace it with print. Well, if you had written this and you'd put echoes all over your code because you didn't have a single line in your program that was responsible for printing, then you would have a really big job and you might miss echo someplace, and then you have an error because your code every once in a while happens to hit that echo and it's no longer there, and people forgot to take that echo out because it was lost because you had a lot of echoes. If you have that echo or any of the system functions, the built-in functions in PHP put in a function like this, then you know that that function that's the one place you would have to go to change. So if my boss said to me, I got to change every echo to print, and I followed the single responsibility open close, I would just have to do this, because every place in my program that had to echo something now calls this function, and I just had to edit the text, the syntax right here, to change from echo to print, and this would fix that potential problem in all of my program, no matter if this print page function was called 100,000 times inside of the program. See, if you don't rigorously maintain your commitment to single responsibility, open close, which basically is the drive principle, then you end up creating programs that are unmaintainable and will create extra work and are more prone to bugs and security problems. Because on a regular, just like you get cell phone updates, just like you get app updates for your phone or updates for your computer, those updates are coming through software development at 10 times the rate at which your code, at which you see as a consumer of technology. So languages today can evolve very rapidly, and libraries can evolve very rapidly because there's a constant battle in the security space to plug holes in code to make everything more secure. So in order to make your code secure, you have to make it easy to update so you can update it frequently. Well, what will happen is the libraries and computer programming languages that you use have regular or frequent updates. So if you don't practice the single responsibility open close principle actively, because the updates happen so fast, you're always going to be taking too much time fixing old code to make it compliant with the new updates that have now come. So it's really important that you always obey the open close principle. Now, whenever I first write my computer programs, I don't write them perfectly the first time. I write them like this. I just sort of write the first attempt at the best way of doing it that I can come up with, and then I get the program to work, And I try to maintain open close and single responsibility as best I can, but I'm thinking through solving the problem and looking up code on Google to figure out how I do a certain thing. And so I'm really not totally focused on my grammar. I try to pay attention to my grammar, but I don't always. So like this program has numerous mistakes in it that I would go back and fix. And so that's what's called refactoring. So in the refactoring of this, if you would look at this, you could see a couple instances. You see that we have a TR and a TR here, TR, TR. This right here could be is repeated line. So because that's a repeated HTML tag, I would start to go and make a function for table row and make it like this, where I have $HTML equals tr row tr return HTML, and then I would go and rework this code right here to call this function and pass the data in for headings into the row. So I would then go and take the th and I would make a th function. I would make a td function to return the table cells, the table columns. TR is the table row, TH or TD are table rows, or columns, sorry. So what happens is you make the first attempt you can, the best way to your ability to get the program to run and for you to understand the code. Planning it out along the way to the steps that we have done. And then you should take that code and then refactor it to rebuild it to improve it. Okay? So the idea here is, just to review, your big ideas that you really want to look into are when we look at the assignment is you first want to get it to read the CSV file and output the table. Okay? That's how you get 100 points there. However, you're going to lose 50 points if you're not conforming to OOP style, which means that you have to use proper grammar. You have to use statics properly. You have to use objects properly. Where appropriate, you should use a design pattern. So for example, the correct design pattern for creating CSV, so the records that are in a CSV file are returned in the array like we spoke about, you should use what's called a factory pattern. So if you would look up PHP factory pattern, and this would be a factory pattern. So this, what it would do is, in this case, see there's class automobile. Class automobile takes in a make and model. And here's the factory. So class automobile factory, public static function. So create a car, so it would return a new automobile. So you'd have a class for automobile factory. You'd have a class which is automobile. Automobile is the actual object. And then that would be a row in your CSV file. And then we would have a factory to return back the records in our CSV file as objects. So in order to conform to OOP style, you have to use design patterns, you have to use correct, you have to use open, close, solid, single responsibility, open, close, dry, and you need to correctly use statics and objects. Okay, so I'm gonna do another video. The next video I'll be recording in a few days during class, and I'll be posting it. But this basically caught up with everything we did in class, and hopefully you will be able to start working on the program this week. What I'm going to do in the next video is show you how to set up the project, get everything running in PHP Storm, show you a little bit about using the version control while we code, but I'm going to record that in class this week. So take care. Bye-bye.